Okay, cool. Welcome, everyone. It's very nice to see that we have a full room again. I would like to share the third part of this three-part series. Some of you have seen the first part. Almost nobody has seen the second part, which is okay. And this is the final part, and I guess the most interesting part as well. Before I dive into the actual topic, I always like to advertise a little bit about the Python user group, right? So Python, as PUX stands for Python User Group Singapore. We are a non-profit society. Basically, we started this entity so that we can collect sponsorship money when we organize PyCons in Singapore, the Python conference. We have a website here, which you might want to check out. You can become a free member, which is basically subscribing to our newsletter. And whenever we have any interesting events going on, we will announce that on this blog. And also if we upload new videos about talks that we are doing, we announce that on that blog as well. It's a very, very low volume newsletter, maximum 1 email per month, mostly, not even every month. And if you want to be aware of future meetups that we are doing, either here or at other locations, you can subscribe to the Python User Group Singapore group on meetup.com. We schedule all those events there. I will also share this QR code at the very end again, where we have a private Telegram group of Python enthusiasts in Singapore, right? So this link always changes every time when we give a talk every month. So everyone in that group is somebody who has been to the meetups in person. So you can be sure there are no bots and scammers and whatever in that group. Okay, so I'm going to share this again at the very end as well on the last slide. Yeah, so my name is Martin. The talk, I'm not so sure how long it will be, so maybe we should keep questions to the end of the talk, right? I will definitely be here for as long as necessary to answer all questions. Usually at the end, there is always a nice little conversation going on between everybody in the room, so we should definitely take that opportunity later. I came to Singapore 13 years ago, started my own web agency. Through that, I became the CTO of an online art gallery, which you can see a screenshot here, called theartling.com. And I'm obviously a member of the Python user group, so I've been the one who's trying to get speakers every month so that we can have some talks every month. So I'm organizing the monthly meetup, and I've also been organizing the annual conference for the last 6 years before COVID happened. So for those of you who haven't seen it, part 1 of this whole series, you can find this on GitHub, right? So there's going to be a link to the slides, a link to the video, and some installation instructions if you want to try this YouTube summarizer program on your own machine. So what we did there was we downloaded audio from the YouTube video, then we transcribed it using Whisper. Then we turned this text into chunks of no more than 14,000 words. And then we sent that to OpenAI with the instruction to please summarize this text, okay? So then the second part was very similar. Just that this time we did it with Kindle books. So basically I have the Kindle app open. As I'm reading the book, I will take screenshots with a shortcut on my keyboard. And then all these screenshots, I would use PyTesseract to extract all the text from the screenshots. And so then it's the same like with the YouTube audio, which has been transcribed into text. The text from the Kindle books is also transcribed into text. And then I can do the same thing. Send chunks of 14,000 words to ChatGPT and ask it to summarize the chapter of the book that I've just read. Yeah? So let me show you for a second maybe Logseq. So what am I doing with all these summaries, right? I've been doing this for basically a whole year already. So I have hundreds of these summaries over here. Every time when I watch a YouTube video, I'm gonna summarize that, and it turns out into something like this. Yeah? So there's some metadata on top. I track the cost. 15 cents for this summary, right? And I add this second brain true attribute here on top so that I can later find the nodes that I want to process further with what we're doing today. Because I have lots of other nodes in here that are completely messy and so on. I don't want them to pollute my knowledge database, right? And then basically here, as always, this headline summary. And then on the first indentation level, there's the actual summaries, right? So this nodes application has this block level way of formatting things. So the indentation level here has some meaning, right? And what's also very cool about this notes-taking app is this concept of having pages that are cross-linked to each other. So for example, let's say talk today, right? If I put square brackets around this, then now this becomes a page, right? So now I can start writing whatever I want about this topic. And maybe this is also somehow related to, I don't know, Python probably, right? So then now I can go to the Python page, and then we can see all the other pages that are already linking to the Python page as well, right? So it's a little bit like a wiki, right? Where there are lots of cross-references to everything. Let me delete this page again. And this is a pretty cool way of dealing with knowledge, I guess. It can then build up a graph of everything that you know, basically, right? So there seems to be a topic here that I write often about. Oh yeah, right. I was recently developing slides for a statistics course, so I had to learn a lot about statistics. So there's lots of notes that I collected for this topic over here, right? So yeah, this is a pretty cool notes app. And what I really like about it, so it's very similar to what you might have heard. Roam Research is one that blew up last year, but then somehow didn't go anywhere. And Obsidian is the one that almost everybody knows about, right? But what I love about this one is that it's all locally on my own machine. So, I can put these things into encrypted drives, and, I could, have different volumes here. This one is my normal knowledge graph, but I have another one which is in an encrypted drive where I write my own journal, my own diary, so to speak, with with intimate thoughts and so on, which I don't ever want to share with anyone. So I don't think you can do this easily with all of the other apps, because mostly they sync through the clouds, and I don't want my stuff ever to end up in the cloud. So the main reason why I like this Notes app here is because everything is local on my machine. I still figured out using iCloud Sync to get syncing done anyway, so it's synced on my phone as well. At least the public notes where I'm okay to sync it, right? And for the encrypted one, I simply don't sync them at all. So what are we trying to build today? So I have all these notes now, right? All down here, all these notes over here. And of course, over time, I can't even remember what I have noted down, right? So usually after half a year, I keep forgetting what I have seen and what I have noted down before. And so taking notes for my whole life, I've always done it, has become like a black hole, right? My Notes app is a black hole that sucks in all this knowledge, and they never resurface again, which is, then it means taking the notes was a waste of time in the first place, right? So what we are trying to build is, we will write a little Python script that scans the entire Logseq notes folder, all these markdown files. Each page here is a single markdown file, yeah? And looks for those files that have the second brain true parameter here on top, this one here, right? And then we will convert every single sentence, so like this sentence here, right, and then the next one, into a vector using OpenAI embeddings, okay? And then we will ask a question on the terminal, like, what do I know about vitamin D and its effect on sleep, whatever, right? And this question can also be converted into a vector. And so then we can find the vectors in my notes that are nearby my question vector. And so those sentences seem to be talking about the same stuff as my question is asking about, okay? And then we will take all the notes that we have found that seem to be related to my question, and we will put them into a big prompt and send all that information to ChatGPT and ask it to answer the question based on the data that we have provided, okay? So, okay, I've already described what Logseq is, right? So the link is also here if you want to download it and try it out yourself. It's actively developed. Every few weeks or so, there's a new version coming out, although it seems to be stable. I never even realize what the new features are because I never see anything new. But yeah, it just works. It's great and it's fast. What are embeddings? So like I already hinted, embeddings are ways to turn text into vectors, okay? OpenAI has a really nice blog post about this where you can learn why this is useful. Like here we have some text. We run this through OpenAI's embedding model and it spits out numbers, okay? And just yesterday, they released a new model. So it used to have 1,500 dimensions, the vectors that come out, and the new model that they released yesterday has over 3,000 dimensions. And they have another model that's, I think, I don't know how many dimensions, probably a little bit more than 1,500, and both of these models perform much better than the old 1,500 dimension model that I was actually using when I made these slides. So why do we need vectors? I also hinted to that already. Imagine if we only had a three-dimensional vector space. Yeah, so we have 3 dimensions over here, and the vectors are like pointers into a direction, right? And maybe we have calculated the vector for king is like this, and the vector for man is like this, right? What we can already see is that all the vectors that deal with humans seem to be pointing in the same direction, but vectors that deal with fruits or with animals point in completely different directions, right? So if this vector engine is well trained, all the things that thematically belong together will be near each other in the vector space, right? And we can use that to find, to do a semantic search, right? We are all used to keyword search, where it literally searches for exactly the term that we have entered, and that was well and fine for all these years that we have been using computers. But now, luckily, we can do something like semantic search, where I don't have to enter the exact keyword. It's not a full text search anymore. I can explain roughly what I'm searching for, even if I don't know the exact term. It might still find what I'm looking for, okay? And we will see that later when we try it out. So we will be using a library called FAISS, which was developed by Facebook. So here's the GitHub page. It's pretty scientific. And there's also a blog post where they describe how they scale this up. And so the cool thing about FAISS is that it's probably the fastest vector index that we have right now. They filled 1 billion vectors into this, and they are still able to find nearby vectors with a pretty good accuracy in like 1 millisecond. When you go up to 10 milliseconds, then it's 45% of finding good vectors, which sounds like very little, but we will see later. The results are amazing. It will find very, very meaningful vectors almost all the time, right? And it's incredibly fast, even if you have billions of vectors, okay? So, and it's an in-memory vector store. So we will be building up that vector store every single time when I make a query. I will soak up all the vectors from my database, put them into this FAISS thing, and then I will make a query and try to find nearby vectors that are nearby my question vector, okay? So then we will build up a prompt for ChatGPT, and it will look like this. We will say, answer the following question based on the provided context. Each part of the context starts with source and then the name of the file and ends with a blank line. If you cannot find an answer based on the provided context, then you just say insufficient context. And if only a few sources are relevant, just ignore the irrelevant sources, because sometimes it will derail itself, and the answer will be like, oh, there is a lot of information here, but there's a lot of other stuff that is not relevant to your question. I don't want it to tell me about the irrelevant stuff. There's always vectors that we will find that are completely irrelevant to the question, and we just want ChatGPT to ignore those, right? And then at the end, also list all the sources that you have used in your answer. Then here, at this position, we will enter our English question that we have typed into the terminal. And context here, at this position, we will be putting all the sentences that we have identified to be relevant to our question. This can be just a few, if I don't have many notes about that topic, right? It could be hundreds, right? So, of course, I will make sure that I never overwhelm ChatGPT with too much information here. So, you have all not been here for the last talk. There was a very funny moment when I was trying to make a diagram, and for fun, I asked DALL-E to make it, and it came up with completely stupid infographic that had not even real English words on it and everything. So let's see if DALL-E has become better at making diagrams. So I asked ChatGPT, please make a diagram of this process here. We have a page with nodes. Each sentence on the page gets converted into a vector. All vectors are stored in a FAISS index. The question is also turned into a vector. The cosine distance search is performed to find the nodes that are relevant to the question. A prompt is created which contains the question and the relevant nodes. The prompt is sent to ChatGPT. I mean, I could have drawn like a little, lots of boxes with all the things that we are doing and some arrows in between. That's the boring part. Let's see if AI can do it. No, it can still not do good diagrams, right? So very funny. So it has all the elements that I asked for, I guess. It once again has fake language. It's not really English, so that's pretty funny. Okay. By the way, what we are doing here, what I'm trying to build here, is actually called retrieval augmented generation, yeah, RAG. You can Google for RAG Python tutorial. You will find hundreds of medium.com blog posts where people describe how to build something like this. This is kind of like all the rage right now because LLMs are amazing. You know, ChatGPT is super smart and super cool, knows everything about everything, but of course they hallucinate all the time. And how do we make sure that the LLM answers based on most up-to-date information? That is what everybody wants, right? And this basically solves that problem. The most up-to-date information, we will store that vectorized in some database. And then when we ask a question, we first retrieve all those vectors, and then we tell the LLM, tell me what you know, but also keep in mind, I have this extra information for you, right? And so then it's less likely that ChatGPT will hallucinate some nonsense, right? Because we are giving it, hopefully we are giving it the answer already. There's a nice blog post here that describes what RAG is using a library called LangChain, also in Python. And that's actually a pretty good diagram here, right? We have a question, we convert that into a vector, then we find nearby vectors. From those vectors, we create a context, we send all that in a giant prompt to ChatGPT, and then ChatGPT will give us a response. This is what we're trying to build today as well, right? Okay. Let's get started. So as always, right, I designed these talks for beginners, people who want to learn Python, who want to see how it looks like and feels like to build something in Python from scratch. So those of you who already know Python, this will be a little bit basic and boring maybe, but never mind, this is gonna be very quick as well, right? So whenever I start a new project, I will obviously start with making a folder on my computer somewhere for this project. So the mkdir command means make directory, right? So in my projects folder, I will create a second brain folder, and this is how our project is called today. And inside that folder, I just make another second brain folder. So I'll do this. And then the cd command means change directory. And so I will be going into projects second brain, okay? When I do ls, we can, oh, why is this already in here? It shouldn't be here. Let me remove this folder first. And let me try this again. Okay, so when I do ls, it means list. It shows me all the files that are currently in this second brain folder. And there's nothing else other than the other second brain folder that I've put in here, okay? So the next step after I've made my project folder is I generate a bunch of files that usually, because I'm obviously experienced, I already kind of know what I want to do before I even start coding. So I made a lot of files right now here. I just created them. The touch command creates files, okay? And if you would try this at home, then after that, I would do the tree command, and then you can compare if your file system looks the same as I would expect it to look like, right? So what we can see here is inside the second brain folder, that's where I put all my Python code, right? In the second brain folder, I usually put things like the README and the requirements text file, which I will explain in a second what that one means. Yeah? And you can see, I mean, when you design your project, I already outlined roughly the steps that I wanted to do, right? For example, over here. You can always come up with the steps that you want to do in your program. So I kind of made files for that, right? I know that I need to gather data somehow. I need to find all the nodes on my computer. We need to somehow build up this vice index, right? We need to get embeddings for every single node. We need to interface with an SQLite database, and we need to ask ChatGPT. So for these different tasks that I already know roughly that we probably need to do this, I created files for that, okay? It's always good not to put your entire Python code into one gigantic file, but to split it up into many, many short, small files, okay? So once I've created my folder structure, I start Visual Studio. I do this by typing code space dot. That means start Visual Studio here in this folder, right? So now I can see all those files that I've created, okay? They're all empty, okay? So let's start filling out these files, okay? We will start with the git ignore file. Always, that's very first, it's always the git ignore file. So here, basically, If you plan to publish your work on GitHub, then there will always be certain files that you don't want to share with the world. Usually my projects have a local settings file, which is where I put secrets like API keys and passwords and things like that. And you would never want this to end up on GitHub so that the whole world can see your passwords, right? Or for example, we will be building up a SQLite database. And so that's going to be a file that's sitting in here. And this database will contain all my nodes and all my vectors. And this is going to be a very, very large file, 300 megabytes or so. And I don't want to publish that with the world as well. I mean, there are literally my notes in plain text in there, right? This is personal information. And also, when you put something here into the gitignore file, these files, when you open them and you have GitHub Copilot installed, then the AI will not look into these files. So once again, so I'm using GitHub Copilot in my daily work. So if I open any kind of code file and I start typing, like for example, make a for loop, and I press enter, then it's okay. Oh, wow. Oh my God, it comes up with a project idea here. But you see, the AI is suggesting things that I will do, right? And that means my whole file will constantly be sent to Microsoft, and then they will send me back suggestions of what I might want to do. And if I would send them, if I open the local settings file, and my secrets would then also be sent to Microsoft, which I don't want, of course, right? So if you put this into the gitignore file, then nothing that you do in those files is going to be sent to any AI company, right? Okay, so that's the gitignore file, right? Files that we don't want to share with the world. Let's look at the next one, the local settings file, okay? So here you have to insert your OpenAI API key, right? So you will go to openai.com, you will log in, and then here, API keys, then you can create a new API key over here, right? And that key is what you want to enter over here. Then also I provide a path here to this folder where I want the database to be, and I provide the name of the database over here as well, okay? And then there's going to be one variable here where I provide the path to my Logseq document. So that's the folder where all my markdown files are from my Notes app, okay? So I've actually prepared this already over here. Let's copy this from here. And let's put that into my local settings file. So tonight I have to remember to revoke this API key, because now it's going to be on YouTube and everybody can waste my money by using my API key, right? And ask questions to ChatGPT. Okay, so now we have this. So yeah, next is the requirements.txt file, okay? So as you develop your Python programs, you will usually encounter a situation where you need something from the internet that someone else has already built. Usually you Google around, like how can I count tokens for OpenAI prompts, and then you will learn there's this tick token library, and you learn that you have to type something like pip install tick token into your terminal, and then that library will be downloaded, okay? So then when you download that for the first time, then you can see here it has downloaded version 1.26.13, I guess. And then you would, no, that was not the right version number, but tick token, 031, I think. So no, that's also not the correct one, but never mind. Normally when you pip install, you can see what version number it has just installed. And so you take note in your requirements.txt file, okay? So then, because later on, maybe half a year later, you want to continue working on this, and maybe you have a new computer already, then you need to install all these packages again, right? And you probably have forgotten already what you need. So if you have taken notes in the requirements.txt file, then all you have to do is pip install -r requirements.txt, and it's going to install everything that's in this file, okay? I will do this in a second. You should usually not install Python modules and packages into your global system Python installation, like I just did with tick token. It would be better if you first install something like pyenv. I have the link here, and the pyenv virtual env plugin, okay? And then once you have installed this, you can do something like this. You can say on the terminal, I want to create a virtual, maybe let me clear the screen. I want to create a virtual environment called Second Brain. I already have that one, so nothing much happens here. this will create a folder somewhere on your computer called Second Brain. And inside that folder is an exact copy of your original Python installation, okay? Then you have like a sandboxed version of Python. And if you break that Python by installing bad packages or so, then at least you don't damage your operating system, your global system, right? So after we have created this environment, we have to activate it. And Second Brain, okay, that's a typo on the slides. And then once I've activated it, I can finally do the pip install requirements text, okay? This is super fast now because I've already done this at home, so my environment was already there. Normally it would now take a little bit of time, download all these packages that are in the requirements text file. So now in this virtual environment here, there is my original Python plus these packages over here that we will need for this project today, okay? Alrighty, so let's get started with actually implementing the different things. So the very first thing that I need to do is I need to find all the nodes, okay? First of all, here, so that you can imagine what's going on, let me show you this folder over here. If I go into that folder, into that folder, and I do ls, we can see there are lots and lots of markdown files, okay? All of my nodes are here. Every single page is one markdown file, okay? So let's jump back to the original folder, Second Brain. Okay. And so what we're doing here is we are changing the directory to that folder. And there are many ways how you could, damn it, I've deleted everything. There are many ways how you can use Python to, find a lot of files. But I already know in Linux, I can find my files with this command down here. Oh, by the way, yeah, I should have stayed in that folder. Give me one moment. So once again, cd here. So if I am in that folder, I can run this find command over here in macOS and Linux. When I use the mouse, it goes to the next slide. Let me try from here. Okay, so this command basically says search for all files that end with MD, and then look into those files and see if the text Second Brain true is in that file. Okay, and then this gives us this output over here. Okay, so in Python we can use the subprocess module that is already built into Python. Okay, and this basically allows us to run terminal commands from within a Python script. Okay, so here I have crafted my terminal command, the one that we've just seen, and I'm saying I want to use my normal shell and I want to capture the output. That means when we capture the output, all this output that we see here ends up in this variable files over here. Okay, and so this is just going to be one gigantic string. Yeah? And so we're going to split that string on every new line, because every line here ends with the new line character, right? It's not one long line, it's many, many rows that we are seeing here. And so when we split by the new line, then in my files variable is now a list of text, a list of all the file names, basically, okay? Here's just a little trick to get rid of, maybe we have empty lines, maybe the last line here is counted as an empty line. That would be a file name that's not there, that I don't want. So we clear that out, and then we return this list of file names, okay? Very, very simple code. You could ask ChatGPT, I have files in this folder, tell me how I get a list of all these files, and it would give you either this kind of code, or it would use other Python libraries that also can look into folders, right? So, and what I like to do is, when I build a little tool for myself, find nodes, right? I always would put this if name equals main down here, and then I call that function that I've just invented, right? I've just invented the find nodes function over here. And if I wanted to quickly test it out, I make some kind of main program here. So now down here, when I go back to the Second Brain folder, I can do this, Python m, and so all my files are in Second Brain. And the file that we've just created is called find nodes, right? So I write the file name over here, find nodes. So I'm now telling Python, please run the find nodes file. And it will look for this main program over here and then execute these 2 lines of code, which means it's going to execute my main function here, which means we should be seeing all our files. So if I run this, voila, I can see here it's a list full of strings, right? Each string represents one file name, okay? So then I can immediately see, okay, what I've just built works. Yeah? Okay, then let's move on to the second file. We are at find nodes, the Logseq parser. Okay, Logseq parser over here. So now I make a function called extract nodes for some file name, right? I have already a list of all my file names, so I'm going to loop over every single file name. And for each file name, I'm going to call extract nodes, okay? So I will first open that file for reading, yeah? And then I will build up an empty list over here. This is supposed to have all the nodes from that file that I found, okay? Then for each line in my file, so remember, these are Logseq files now. So when we say for each line, it refers to these lines over here. Actually, it refers to all the lines, really, yeah? So I can count the indentation level, yeah, by using a regular expression here, looking for either 4 spaces or the tab character. And so basically, this thing here is indentation level 0, okay? Anything that is below summary is indentation level 1, right? This would be indentation level 2, okay? So indentation 0, I don't care about. If I would put some extra nodes over here, like blah, 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 these will not be considered because they are level 0, okay? Only the things that are level 1 will be vectorized, okay? So I'm counting the indentation for every single line, stripping away white space around the line that may or may not be there. And then I check if the indentation is more than 1, then I consider this to be a node that I want to vectorize, and I add this to the list of my nodes, okay? Very simple algorithm once again. You could have asked ChatGPT, I have markdown files, one of those files looks like this, and I want to extract all the nodes that are indented under the summary headline. It's going to give you some nice codes to get that done as well, right? And once again, I want to immediately have a way to test what I've just done, okay? So I make a little main program here where I can put in any file name, and it's going to try to do the thing and show me the nodes that it has extracted. So let's try that. So now this time I'm going to say Logseq parser, and I could copy one of these file names here, right? So if I do this, it doesn't work. Why is that? Logseq parser. Is this file actually called Logseq parser? Oh, I didn't save the file. Okay, so it was still empty. Now when we try again, aha, see, I get a list here with all my nodes, right? Every single line was one node. Here's one node. This is the second node until here. Okay, so we have a list of all the nodes. Basically, if this node here, we have extracted everything from here to here, basically. Okay? All right, so now I have a function that can do that for me. Very nice. What's next? The embeddings file. Right, so now that we have a list of all the nodes, I want to send every single node to OpenAI and get an embedding for it, okay? So let's go to embeddings here. So from my local settings file, you can see I had my OpenAI API key, right? So we import this. Then you have to Google around a little bit, read the OpenAI documentation, and you will learn that you can pip install OpenAI, and then you can import OpenAI. And the first thing you have to do is on the OpenAI module, set your API key. And then any other calls that you make to OpenAI will already know about your API key, okay? So I invent a function here called getEmbedding. This function will take in the text that I'm trying to embed, so one single sentence, okay? And here I'm defining which model I want to use, okay? So this is actually now outdated. They have a better model now. Let's just go with this one for now. It's a little bit cheaper and faster. So how do we get embeddings from OpenAI? Well, we say from the OpenAI library that I've imported here, there is a class called embedding, and it has a function called create. And we throw in the text that we want to convert. This is the same text that I'm passing into this function here, and the model that we want to use. I'm also passing that into the function, but it has a default value, okay? And so then we will get a certain syntax back from OpenAI. If you read the documentation over here, they show you how to do it, right? See, there's Python code here. They show you how to do this, and they show you how the response will look like, okay? So that's how I learned that there's going to be data, and then in data that's a list So the first item in that list is what interests me. And that item has a key embedding. And that is the list of all the vectors, of all the dimensions of the vectors. Okay. So in my code, basically, what I'm saying is, I know that there's a key data, which is a list. I take the first item that has a key embedding, and that's the list of the numbers that I'm interested in. So I return that whole vector. Okay. Once again, I want to immediately test that, right? I make up some fake sentence. I throw that into my function, right? I'm not going to change the default value here, so I don't have to provide that down here. And then I just want to print that embedding. Maybe let's also print the length of that embedding. I would expect this to be 1,500 characters. Okay. So then we will say, what's the name of this? Embeddings, right? So we will say, I want to execute my embeddings file. See, 1,500 dimensions. And we can see that little sentence, this is a test, has been turned into this mountain of numbers over here. One vector with 1,500 dimensions. Okay. All right. So next, the database file. So it costs money to get these embeddings, and it takes a lot of time, right? All my nodes in total has more than 300,000 sentences. And of course, I don't want to, every time when I ask a question, have to load all these embeddings first. So once I get them, I need to store them somewhere. And I thought the easiest way and fastest way is probably just a simple SQLite database. SQLite is already built into Python. Yeah, so you can just import SQLite, and then you can do things like this. We'll probably start down here. Where's create tables? Here. So you say, you make a connection variable in SQLite. Yeah. You say, I want to connect to a certain database. And this is the database path that I have set in my local settings over here, right? Where you can see in which folder I want the database to be and what name should the database have. You can come up with any name. It doesn't even have to end with .SQLite. Totally doesn't matter. It's just any file name. Okay. So we connect to that file. We start a cursor. And then we say cursor execute, and here I'm executing an SQL statement. I actually haven't used SQL in 10 or 12 years anymore. I have no idea how to do it, but I just told ChatGPT, give me an SQLite table with the column ID, file name, content, embedding, and it spit out this code basically, right? And so I'm also saying any combination of file name and content shall be unique. So if I ever try to scan the same file again, it will already see this sentence from this file is actually already in my database. And if I try to insert that again into my database, it will crash because it will say this combination of file name and content has to be unique. Okay. I would still have wasted some time getting the embedding. So I have my create table thing over here. Later, we will need one function to get all the embeddings from all my nodes. So I'm selecting ID and embedding from the embeddings table. Yeah? All 300,000. This sounds like a lot, but it happens in less than a second. Yeah. We will also need a function to get the rows for a bunch of IDs. Yeah. So then we will select ID, file name, and content from the embeddings table, where the ID is in this list of IDs over here. Okay. And finally, we want to store those embeddings. So we are providing each time we are providing a file name, the actual sentence that we have embedded, and the vector for that sentence. And then we insert this into the embeddings table here. Yeah? And this is the part where it can crash if this combination of file name and content is actually already in the database. So I put a try except block around this, and I'm expecting that it can sometimes crash. In that case, it's actually fine. My program can still go on. I'm simply saying I already have an embedding for this file name. Yeah? And once again, see here, I wanted to quickly try this out. So I made my main program, and I'm basically calling all the functions that I have built in here. First, I create all the tables. I once again create a fake test embedding over here. Then I try to store that test embedding. I just make up a fake file name here. And then I'm calling get all embeddings. And since in this situation here, this will be my very first embedding, I expect the lengths of all my embeddings to be 1. There's only this in the very beginning. When I'm running these tests here, there's going to be 1 embedding only. And I also want to try, so I'm expecting this 1 embedding to have ID 1. So I will try to fetch that embedding immediately out of the database as well. So now let's test this. Second brain.database. So it's going to create the table. it's gonna query all the embeddings, and it found one embedding. And then it's trying to get the embedding with the ID 1. So then I'm getting to see ID, sentence, ID, file name, and sentence for that ID, right? So it seems to work. And now we can also see that this SQLite file has appeared on my computer, okay? And you can actually, using the extensions library here from the extensions marketplace from Visual Studio, you can search for SQLite, and you can install the SQLite plugin, okay? Then you can right-click on such databases. You can say Open Database, and then you get this SQLite Explorer down here. You can see your tables, and you can right-click the table and say Show Table. That's quite useful. I mean, you can also download some kind of SQLite browser as a separate program, but usually I just want to quickly look into my table to do some debugging and so on, right? And this is super fast, and I can stay within Visual Studio. So we can see we have the ID column, file name, we have our sentence, and we have the 1,500 dimension vector for that little sentence, okay? So this table, right, this will be filled with 300,000 rows in a moment, where we get the embeddings for all of my nodes, right? From all my files for all my nodes, okay? So that's the database file. And now we want to build this FICE index. So we want to get all our embeddings and store them in this in-memory index database, okay? So let's go to FICE utils over here. And so basically, I had no idea how to do this. I can't remember if ChatGPT told me or if I found this in some tutorial about RAG, yeah? But you will find basically these lines of code very easily on the internet or by asking ChatGPT. So what we're doing here is, every time when we ask a question, yeah, we want to quickly build up this index. Yeah? And so what we have to do is we have to get all 300,000 nodes from our database. Yeah? So we are using a function that we've just built ourselves in the database file over here, get all embeddings. Yeah? This is just a simple SQL statement that selects all the embeddings. Okay. So now here I'm going to have a list with 300,000 items, and each item has the column ID and the embedding vector. Okay, 2 columns. So I just look at the very first item and at the very first vector, and I count how many numbers that vector has. And it's going to be 1,500 dimensions, right? So this is 1,500 something, roughly 1,500 dimensions, okay? So I'm saving this number, 1,500, in the dimensions variable here, okay? So then I'm using a library called NumPy to make a matrix full of zeros that has 300,000 rows and 1,500 columns. Okay, so basically we are building up something like this full of zeros. 1,500 here, and then 300,000 rows like this. Okay, this is what this one line of code is doing. It creates this kind of matrix. Okay, then we loop over every of the 300,000 rows from my database, and we add that current embedding into that matrix. So then the first row will no longer be just zeros, it's going to be a bunch of numbers. And then we keep doing that 300,000 times, okay? And we keep a dictionary here to map the ID in this matrix to the ID in my SQLite database, because this matrix here starts with the first row has the ID 0 actually, but my first embedding in the SQLite database has the ID 1. And maybe later on I'm going to delete a few rows in my database, and so the IDs will no longer be in sequential order. You know, so we need to keep track which embedding, which thing in the matrix here is connected to which ID in my database. Yeah? And so then we call from the FICE library. So when we do pip install FICE, we can then import FICE over here. And then we can create an index with so many dimensions. We have counted the dimensions over here, right? And then we just throw in the matrix. And so then all these vectors will get added into this in-memory index, okay? And so we return the index and the mapping for all our IDs. We will see that in action later. And then once again, as always, I immediately want to try this out, right? So I already have one vector in my database because I tested when I did the database file, I tested to create the database and put one fake vector inside, right? Not even fake, it's a real vector, but it's not an actual file on my computer, right? So I would expect that when we turn this into an index, FICE index.n total should be 1. It should tell me that there's one vector in this index right now. And the ID map should also have something, okay? So this file is called FICE utils. So let's try it out, FICE utils. And indeed, the FICE index has one item, and I can see my ID mapping is a dictionary where in the matrix, in the index, number 0 corresponds to number 1 in my SQL database, okay? You will see later why this is important. Pretty good in time. Actually, already pretty much at the end, almost. So, right, we have 2 steps left. We need to actually ingest all the 300,000 nodes, and then we need to write something to actually talk to ChatGPT, okay? So then let's look at the gather data file. All right, over here. So this file, see, it makes use of all the other things that we have built so far, right? So we are importing from all our own files that we have built so far, right? So now we can say, what do we want to do when we gather data? We want to make sure that our database table has been created. Then we want to find all our nodes. Remember, with our own function over here where we use the find command, right? Then we want to loop over every file name that we have found, okay? Then maybe we make a little print statement here so that we can see that something is going on. We show the name of the file that we are working on right now. And then for this file, we want to extract all the nodes, which we have also written earlier, okay? So now we have a list of nodes as well. So we loop over every single nodes. And then we call OpenAI to give us embeddings for every single node. So we throw that into our own get embedding function here. And then we throw the file name, the node, and the embedding into our database, into the store embedding function over here where we do the SQL insert statement, okay? So, I mean, none of this is advanced Python code, really. It's just simple loops, you know, not even if-else statements here. They're using our own functions. The most complicated thing here is probably f-strings. So if you've never seen f-strings, this is quite cool. If you want to insert something into your text, if you don't know about f-strings, you would do something like this, like parsing file plus file name, and then also need to be a space here, plus, and then this. See, it's going to be very, very complicated to construct this by concatenating strings with the plus operator. If you just put an F in front of your strings, now you can put these curly brackets over here, and you can just insert Python variables that you've created earlier. So file name is a variable here, so I can insert that into the string at this location. Makes it much easier to read what this string is going to be. There's not all these pluses everywhere that was going to confuse you, okay? So gather data looks like this. Of course, I'm not going to let this run all the way because it takes half an hour. But you can see, it has opened the first file. It has identified 10 sentences in that file, and it has gotten all these embeddings. So you can see it's pretty fast. OpenAI doesn't have to seem any rate limiting, so I didn't put any wait command in there. It's doing it as fast as it can, and I've never gotten blocked. And I've done 300,000 requests, you know, without ever waiting. So I have the suspicion OpenAI wants us to dump all our personal data into their embeddings database. And I mean, they have 100 million users, or more, probably much more, right? If 10% of the users use something like this, which I'm pretty sure they will, that's 10 million users or whatever. And if they all upload embeddings, they get an unbelievable amount of data that's not public on the internet, right? God knows what they're going to do with that data, right? But you can see as this is running, if I open my database again, see, now there is actually, you know, that first file is in here and those 10 sentences are here, right? And all of them have embeddings, okay? And then there's the second file. Here's the next file name. That one has also 10 sentences or so. That's the next file name. And it's growing and growing and growing, okay? So, you know, you will probably leave this running overnight, right? I've already prepared this, so let me copy from my documents. Let's take that one over here, and let's put that over here. So this is 160 megabytes. Yeah? So that's 300,000 vectors with 1,500 dimension, 160 megabytes. For example, I tried this morning with the new model that they've just released yesterday, which has 3,000 dimensions, so it's twice as large, and the file is more than twice as big as well, right? So the bigger your vectors are, the larger the file is going to get, of course, right? But luckily we live in a day and age where modern MacBooks have more than 60 gigabytes of RAM. So I think I'm good for a while. I will not be able to write notes so quickly as to ever blow up my memory, right? So I think I can leave this file growing and growing for quite some time, okay? So that's gather data. And then there's the exciting part over here. Ask ChatGPT, okay? So let's paste that in here. So what are we trying to do here now? So I'm using their most advanced model right now, which is also the most expensive one. So on their website, you have an overview of all their models here. Of course, we are interested in GPT-4, and I'm going to use this one here. 128,000 token window. That's actually pretty insane. I'm not going to use that much. I suspect if you use that much, it's not going to really keep track of what's in the context anymore. They are probably lying to us here because their competitors are claiming that they have 100,000 token windows, so they now also have to claim that they can do it. But I don't expect the results to be very good. We are actually fine with just using 30,000 tokens. That is more than enough. I will never have so many notes about one single question that might be relevant. I don't need that much anyways, right? So yeah, you can see these are the models that they have over here. And so I put that model name in here, okay? So here's our prompt, right, which I've shown on the slide earlier. Answer the following question, blah, blah. And this is a so-called format string, right? This string is not complete yet. We will later have to format the string to insert something at this position where question variable is and something at this position where the context variable is, right? So, here we will put something very simple like, what is the meaning of life, right? Of life. And over here, it will always be like this: source, and then some file name .md, and then some note, and then maybe, come on, some more notes. Yeah, so we have seen that some files have many sentences inside, right? And then there might be another file that was interesting, and then there will be some text that was from that file. So it's going to look like something like this, right? If I asked meaning of life, and maybe I had 12 notes in my app that somehow talk about life, they will probably all show up here. And out of those 12 files, maybe in each file, 3 or 4 sentences were relevant to my question. So those 3 or 4 sentences should show up over here, okay? So this is how this prompt will, in the end, truly look like. Right, I always need a function to count if my prompt has exceeded 30,000 tokens already. So, you have to learn about the tick token library. It's also open source from OpenAI. You can pip install tick token, and over here they tell you how to use it. Basically, you just call, where is it? Oh yeah, you call encode and the text that you want to count, and it's going to tell you how many tokens that is, okay? So then here's the actual magic that we are going to do. Whenever we ask a question, we need to build up our FICE index, which we have built earlier. Every time it's going to query all 300,000 nodes from my database, and it's going to create that gigantic matrix and throwing it into the index. And so now they are floating around in memory, right? And FICE will optimize those vectors a little bit. They create subvectors and all that. They make all kinds of unbelievable computer science magic happen so that we can query those 300,000 nodes in milliseconds, okay? So then we have our question, and we are using the same get embedding function that we also use to embed all the 300,000 nodes, right? So we throw that question that we have into the get embedding function, and then our question is also a vector now, okay? And so then we turn that vector, we make sure that it has the correct shape, normalize it here somehow. I found this on the internet. I have actually no idea what's mathematically behind this and why this needs to be done. And now we can say this: from my FICE index, I want to use the search function, and I want to search anything that's nearby my question vector, okay? And give me up to 100 vectors that are nearby. If you don't provide any number here, it's going to give you all 300,000 vectors sorted by distance. And I mean, I'm not going to use so many, and it's probably going to waste time and processing power and memory and all that. So I say, give me up to 100. 100 pieces of text, that must be more than enough information for ChatGPT to give me a good answer. There's no need to search for anything more, okay? So then I'm getting the actual vectors and the IDs that are corresponding to those vectors in my database, okay? So now I can then query my database by IDs and get those up to 100 nodes out of my database. And so then I can loop over all those nodes that I have found and build up this context down here, right? Remember, that's supposed to look like this: source, blah, 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 and then node, right? So that's basically what this file is doing, right? It's trying to build up this context. So for every row, I'm creating the file name, and then for every node, I'm adding that as well. And at the very end, I'm adding a new line character, and then and each time when I'm about to add another node, I'm counting how large is this prompt right now. Is it already more than 30,000? Okay. If it turns out to be more than 30,000, I also stop. That maybe I got 100 nodes that all have very, very long sentences, and I somehow already got to 30,000 tokens, which is very, very unlikely. I don't think it will ever reach the maximum here. But then I also stop. Okay. And so here we do the formatting, right? Remember, the prompt variable here is like a halfly done string where we still need to fill in these variables, right? So where is it? Here I'm saying prompt format, and the context placeholder shall become that big context variable that we built, and the question placeholder shall become the literal question that I've typed into the terminal, okay? Then as debug output, I just want to show the entire prompt. And so here is the magic that we've done in the last talk and the last talk as well. Sending a prompt to OpenAI, very simple. We import OpenAI, then we call chat completion, create. We define the model, which I had defined up here as a variable, okay? And then I say streaming output true. I didn't do that in the last two talks because you have to wait very long for ChatGPT to write the answer. And when you say streaming true, actually after every sentence, it's going to send you what it has done so far. And then on the terminal, we can see the reply coming in slowly, right? So then at least we know that something is going on. And then here, this is basically how we build the prompt for ChatGPT. We just have to do this role user thing and then content, and this is going to be our entire prompt. Yeah? And then here is how we print the streaming response as it is coming back to us. So we now have to loop over this stream, and I didn't even know how to do this. I asked ChatGPT, tell me how to make how to print a streaming response from OpenAI, and I got this code and it just worked. Okay, so and then let's try it out. Hopefully I didn't mess up anything. So the moment of truth. Ask ChatGPT, what is the meaning of life? So this is our prompt. What? Seriously? Okay, let's, I do indeed not have any node that answers this question, right? But we can see what it has done, right? It has created a prompt, and it has found quite a lot of nodes. Oh my God. Okay, here. Answer the following question as truthfully as possible. Here's the question, what's the meaning of life? Here's the context. And then it's always the file name and the sentence from that file that was deemed to be relevant, okay? So you can see it's a whole lot of files, but sadly, not really about the meaning of life, right? Let's try something else. How could AI lead to tyranny? Oh, not lead. Although it probably can handle typos very well as well, so that's not an issue. Okay, got something here that all seems to be talking about AI. So I can already see that it has queried from my index good vectors, right? And so now ChatGPT has to think hard. You can tell if it takes a time, it is writing some long answer. And just now it just immediately said insufficient context, right? So that's why it came back so quickly. Now, when it takes a long time, it's actually a good sign. So, it will increase the ability of central powers to monitor and manipulate us. And it could lead to, big tech companies will become superpowers. It could, it's all about power seeking, probably something about superhumans and whatever. And it lists the sources that it has cited, okay? So let's try another one. List ways to improve sleep. I think I have a lot about that. So as you can see here, quite a lot of notes. And you see, like, I could search for sleep in my Logseq app. It's going to find hundreds of files, and then I have to read all those notes. That's not going to happen, right? I can't do that. But now ChatGPT is going to read all of that for me real quick. And look at this. This is amazing. Reducing stress. Okay. Avoid eating within 3 hours. Yep, that is well known. Get appropriate sunshine exposure. I don't know how that helps with sleep, but it's an interesting idea. Mindfulness meditation, of course. Avoiding blue light before going to sleep. These things are true, right? So it has dug out the correct notes of my 300,000 notes, and I didn't have to waste the time crawling around in my own notes and getting lost in my own notes, right? Or let's try to find something very specific, maybe. So let's have a look here. For example, here's a name, Patrick Brown, right? I think I only have this one page that is about this guy. Who is Patrick Brown? Okay, found quite a lot. Okay, climate scientist. Okay, pretty cool, right? So I hope you can see that this little bit of code that we just wrote here is not that hard. There was no advanced stuff going on in terms of Python knowledge, right? All just libraries that we can easily install that are very well documented online. So this is something that anyone can build at home, right? And then you just need to find, if you're not using something like Logseq and your notes are somewhere else, then querying those nodes and turning them into extracting all the sentences is basically the hard part, right? And so I was actually thinking, should I do a part 4 of this talk? How can we do all of this but without OpenAI? And it turns out we can. Because just yesterday, this guy released Python bindings for the Ollama library, okay? So Ollama, let's check this one out. So this is something that you can just download and install on your Mac. And you see this little llama up here, it's running right now, okay? So if you've installed this, then you can do things like this. Ollama run Mixtral, for example. Mixtral. Okay, so it's going to load the model. Okay, last time it didn't take that long. Or maybe while it's loading, let's already discuss the rest. So there's going to be a list of models over here, and it's a whole lot of models. All these open source models, usually all the Llama-based ones, you can easily load them here. You can click into every one and learn a little bit more about it. And okay, it's ready. Hey, buddy. What's going on? Bam. This is like ChatGPT, but on my own computer, right? It's obviously not as smart as GPT-4. So now look at this. So I tried 10 of the most popular ones, okay? And it's quite disheartening, like they are really shitty. They are unbelievably fast, so you don't have to wait for the answer as long as you do have with OpenAI ChatGPT, and the streaming response is actually word by word, so that's really awesome. But they do not follow the prompt instructions very well. And especially if there's a lot of context, they start writing essays about the stuff that you've just given them. They don't answer your actual question anymore, right? So, but Mixtral, I found, it's down here. It's like a mixture of experts kind of thing, and they say it outperforms many of the other models in many regards. I found that one to be pretty damn good. Yeah, let's try it. So we could actually replace just this little bit of code here. here and ask ChatGPT, instead of, where is it? Down here. Instead of sending our prompts to OpenAI, we will use Ollama instead, okay? So we are now doing this, and we are not doing this anymore. You can see Ollama, they try to have the same API as OpenAI. Yeah? So you see this stuff over here, it looks exactly the same as down here. Yeah, and the stream true is all the same model, right? So and here you can put in any of those models from the Ollama website, and you can just play around until you find a model that does what you want it to do. Okay, so let's try. Let's do an easy one. Who's Patrick Brown? Again. So the same vectors as before, obviously. That is always the same. And now it's probably loading Mixtral in the background. The first time it's gonna take some time. Oh yeah. Oh, but it appears there are several sources. Okay, yeah, it always comes up with that. Okay, it failed. What the hell? Wow. Okay, it's just listing sources now. How list ways to improve sleep. Let's see if it can do this. Okay, what? Okay, here's some. Okay. Okay, I don't know why it's not doing this anymore. When I was testing this with lots and lots of queries, they were all very good. Now, not anymore. So I probably, I don't know if, did I reduce the context to less, maybe 15,000? And then maybe here, I think I did something to make the response smaller. Let's try again. Yeah. What else do I want to show? Ollama. Oh, I forgot what I wanted to say now. Yeah, no, it's still not really. It's just summarizing the text. Okay, if it tries, that's the thing. If it tries to just summarize the text, it means it has forgotten about the initial instructions. So that means the context window is somehow too large, right? I guess I can probably keep tweaking this. Let's go down to, let's say, 5,000 tokens only. And let's see, try again. Nah. Yeah, that's probably one. But if I already reduce the number of tokens, then the prompt will become smaller and smaller anyways, right? It could also be that maybe we have to move this to the bottom so that it definitely remembers the question at the end, provide a context. Let's try this way. Yeah. It is definitely about it's forgetting the question because it's too far out at the top. So you have to figure out what's the optimal size for the context somehow, right? But yeah, these are blue light, reduce stress. Yeah, this is pretty much. Yeah, okay, but you reduce liver fat. I mean, yeah, okay, that's may work, but it's see, we are so close, right, to something that pushes humanity forward in unbelievable ways. If we get something like GPT-4 intelligence, but we can run it locally and we don't rely on OpenAI anymore, then we can build amazing tools. Like we are almost there. I can play around already, and it kind of works sometimes, but not always. GPT-4 kind of works always, right? So Facebook is currently building Llama 3. They've bought like 300,000 GPUs, and they are now training Llama 3. And Zuckerberg had this stupid video where he was promising to make as much open source as he possibly can. So if they release Llama 3 as open source, and if that's at least as good as GPT-4, holy shit, we will have some real fun building really cool tools, okay? So yeah, I hope this was useful to some of you. If you want to join our Telegram channel, you can scan this QR code and join us, and hopefully I'll see some of you again when we have more talks coming up. And that's it from my side. And of course we can, oh yeah, you want to say some words about, yeah, okay. But I will still be here for answering questions as well. Okay, thank you very much.